Welcome to this tutorial on CIVA Education RT module. The goal of this tutorial is to help you familiarize yourself with CIVA Education modeling software. It will explain a simple case relative to a radiographic inspection in detail. Open CIVA RT by clicking on the RT tile. Choose an initial configuration, for example planar specimen, gamma ray source, film, and click on OK. Once CIVA RT is opened, you have access to the different menus that you will use to describe the configuration. The configuration itself can be visualized in a 3D view. First, define the specimen by clicking on the Specimen menu. A new window appears in which you will define the geometry of the specimen and its material. To define the geometry of the specimen, you have to select an item in the drop-down list. Select a planar specimen. Then, modify the thickness of the specimen to 35 mm. You will see that the 3D view is instantly refreshed when you modify the dimensions of the specimen. Then, define the material of the specimen. To do so, select the Material tab. Choose Aluminum in the Material library. You can reach it by clicking on the folder icon. Load the material to update the configuration. Once this is done, you will define the source by clicking on the Source menu. A new window will open in which you will select the type of source, define its geometry, and its physical parameters. You have the possibility to simulate X-ray or gamma ray sources by selecting the chosen option. Select X-ray. The General tab will allow you to describe the geometry of the source. In this case, leave the default values for the radius and conical angle of aperture. The Parameters tab will allow you to define the physical characteristics of the source. Key in a value of 10 mA for the intensity. Then, select a spectrum of acceleration voltage equal to 100 kV by loading it from the library accessible through the folder icon. When you click on Load, the selected spectrum appears in the Parameters tab. Once this is done, you have to configure the detector. To do so, click on the Detector menu. You will have access to a new window in which you will define the type of detector, its geometry, and add a filter if necessary. Silver films and image plates can be modeled by selecting an item in the drop-down list. In our case, we will model a silver film. Choose a Kodak T200 film from the library. The geometry of the detector will not be modified. Select the Filter tab. You can add or remove the filter by clicking on Add a filter. Here, we will not simulate any filter, so untick the Add a filter option. You can see that the 3D view is refreshed. You have defined the source and the detector. Now you will define their positioning. To do so, click on the Inspection menu. Then, select Source to modify the positioning of the source. The parameters corresponding to the source are defined here. The coordinates of the source along the z-axis will be -1000 mm. The other coordinates are not modified. Now we will modify the positioning of the detector. Click on Detector, then modify the value along the z-axis from 101 mm to 36 mm. You can also model a flow in your configuration. To do so, click on the Flow menu. You will have access to a new window in which you will define the geometry of the flow, its material, and its positioning. A flow is already modeled in that configuration. It can be removed by clicking on the cross button, or you can add one by clicking on the plus button. Two types of flows can be modeled in CIVA Education. In our case, it will be a spherical one. The radius of this flow will be 2 mm. The flow will be made of carbon. Select the Material tab, then click on the folder icon to browse the library of materials. Modify the positioning of the flow as shown. The new coordinates are 20 mm along the z-axis, 90 mm along the y-axis, and 45 mm along the x-axis. Penetrometers can also be added to the configuration. To do so, click on the IQI menu. you will have the possibility to choose the type of IQI to define its material and its positioning in the specimen. For this tutorial, let's choose wires IQI. According to the thickness of the specimen, the ninth wire must be seen, so select the W6 IQI. Select the Material tab and define the material of this IQI as aluminum. Switch to the Positioning tab to modify the positioning of the IQI. Modify the coordinates along the y-axis from 90 mm to 80 mm. All the input data is defined. We will now configure the computation options. To do so, click on the Options menu. You have the possibility to take the blur of the source into account by selecting the Geometric option, then defining ×10 factor. You can define the options of the detector by switching to the Detector tab. We will take the granularity of the film into account. Define a fog value of 0.2. In the third tab, the general options for the whole computation can be defined. Leave the default value for the time of exposure. We will calculate the Monte Carlo, the scattered radiation. Select the Monte Carlo option and click on the Estimation button. Please note that in CIVA Education, the Monte Carlo is simplified. Finally, you can run the simulation by clicking on Run. The optical density obtained is around 9.2. To obtain a more accurate value, we will use the Post-Processing tool. To do so, click on the Post-Processing option from the toolbar. A new window appears in which you will select exposition time as the researched value. Modify the optical density from 3 to 3.2. Click on Apply, then on New. To see the new results, click on the plus button from the CIVA Manager and display the results. The optical density value is now around 3.2. You can also display the profile along the x-axis. Thank you for watching this video. If you want more information, please visit our website or contact us at contact@extend.com.